Hello, and welcome to another one of these ADD videos. Today we're going to look at the concept of derivatives, what they're going to be used for. One more time, we looked at it once previously in the definition of the derivative video, if you remember, with the limits. But now we're going to start looking at the more direct way of finding derivatives. And we're going to start off with the power rule. All right, so before we get into the power rule, let's look at some of the concepts that derivatives will be dealing with. But let's talk about what a derivative is first. When you think of derivatives, you should think of rates of change. Slope is a rate of change, and in this case, the slope we're talking about, rise over run, change of y over change of x, is going to be the slope of the tangent line. Remember, the tangent line touches your function at one point and one point only. And there are various uses of knowing what the slope is of your tangent line. Derivatives can also be used to find the change in one variable if you're given that value of the other variables changed by a specified amount. Okay, and you can use it to predict how much change in output would occur if you changed the number of labor hours or something like that. Derivatives can also be used to estimate error, whether it's propagated error, whether it's relative error or percent error. You can use derivatives to approximate it. Also, we can use derivatives to approximate numerical values. Like if I wanted the square root of 17 or 15, I can use derivatives to do this with a high degree of accuracy. You'd be surprised. Derivatives also can be used to look at slopes of tangent lines, as we said, but over ranges of numbers. We'll find things called critical points and test them to see if they're maxes or mins, determine where the peaks and the troughs occur in your graph, and discuss concavity. We'll also look at instantaneous. I discussed that earlier, the tangent line slope at a specific value. And finally, related rates, we will look at the use of derivatives to look at rates of change over time. All right, so this is the big picture of derivatives. We're going to see this over time the next months or so in your class, so don't panic with all this here. I just wanted to introduce you of when you should think of derivatives. The power rule. The power rule deals with any polynomial expression that's added or subtracted that has a general form of some constant in front. A is a constant. X is the variable. We know that because it's a function in terms of x raised to some power of n. And when you're deriving that, what you do is you bring the n down in front, multiply times the a to get n times a, and then what you do is you subtract 1 from the exponent. Subtract 1 from the exponent to get n minus 1. All right, so again, bring down, multiply, and subtract 1. Get n times a x to the n minus 1. That's basically it for the power rule. A couple things to remember is that it only works if the variable's in the numerator. Okay, so if you got to bring it up, bring it up. You probably might have forgotten your algebra. Believe it or not, algebra and trig is what trips people up the most in calculus, not the calculus. And if you have something in the denominator and you want to move it up, just make it a negative exponent, right? You guys remember the rule? If you have a 1 over x to the a, that becomes x to the negative a. All right? Anytime you want to switch, just change the exponent only. All right, so the next rule is an algebraic rule dealing with roots. If you remember, if I have a b root of x to the a, that can be rewritten as x to the a over b. All right, then you can do your bring down, multiply, and subtract 1. Don't forget to get the common denominator when you subtract 1 from a fraction. All right, that's basically it for the power rule. I'm not going to bog you down too much. You're just getting started with derivatives. You'll see that the course is going to ease up for a little bit. It's going to be purely mechanics for product rule, quotient rule. There are different rules for exponentials, logarithms to take derivatives. All right, so this is just the very first, most basic one. Make sure it's in the numerator, and make sure that you change to fractional exponents first. All right, as always, practice, practice, practice. Check out the beginner, intermediate, and advanced problems. They won't get too bad on these, but believe me, it's going to get more challenging. I hope I've cleared up enough confusion for you to try some problems. Thank you and have a nice day.